This is Data Science, What, Why, How. If you thought it was going to be something else, now is the time to stand up and walk out. Excellent. So my name is Dicken. I'm a senior data scientist at Zynga, technically, officially on paper. I'm also an acting product manager for the data science team, but that transition hasn't really finalized yet, so I do not have an official product manager title on paper yet. A little bit about me to give you some context for this talk. I have been claiming to have nearly 4 degrees for a little while. I promise, for those of you who've been following along, that the PhD is almost finished this time. I've just got some corrections to make, and they want to see them in the next year. I'm also a director for the IGDA. I'm chair of the IGDA Foundation, and before that I've been secretary for the IGDA last year, chair of IGDA Scotland, head of the IGDA Scholars Program, because I never learn. I founded a small studio called Robot Overlord Games. We did contract AI, consulting and a bit of indie dev out of Glasgow. There's not a huge game scene in Glasgow, so when somebody offered to move me to San Francisco, I said yes. And I was also on the Develop 30 Under 30 for 2013, and that seems like one of the most arrogant bullet points you're going to see probably today, but I like to slip it in anyway. In terms of my career at Zynga, I started in November as a data scientist. I took a brief stint in spring where they moved me up to head up the new IP division and part of the leadership team there, kind of working on data and data science-y stuff, but kind of in a different kind of context. And then in May, you may have read that we had some reorganizations and other things. And since this is being recorded, I should probably gloss over that really quick. And I bounced back to the data science team, and kind of as I've been coming through, one thing that I was noticing was that was this disconnect between these data scientists who were really great math people and actually getting that into games. So I kind of identified that the way to frame that in Zynga speak was product management, and they've moved me across to be a product manager for the data science team. So let's start with a hard question. What is data science? So if you ask Wikipedia, data science is the extraction of knowledge from large volumes of data that are structured or unstructured. Then it waffles on for a bit, and then it gets to another key point, which is that data science often requires sorting through a great amount of information and writing algorithms to extract insights from this data. And that kind of tells you a little bit about what it is, but in a very opaque way. Effectively, data science is a new and emerging field, and it's one of the hot new things that's happening in tech in general, San Francisco in particular. If my LinkedIn recruitment thing is anything to go by, Jesus Christ, if you have data science on your profile, they will contact you daily. It's the intersection of computer science, stats, AI, anything that you can kind of think of about kind of insights and analysis and all this kind of stuff. And because of the amount of data that we have available these days, oh geez, this podium moves. I'm going to stop leaning on that. Because of the scale of the data that we have available, like, we have huge opportunities to do kind of big data stuff. And that is basically what data science is, using the data that we're gathering in our games, the analytics, the tracking, the stats, whatever you call it, and however you kind of refer to it. I hear it various different ways depending on who's talking to me. But it's about using the event tracking from the games to figure out why people, not why, what they're doing and what they might do later. So analytics, that tracking tells you what's happening in your game now, and by now that might mean yesterday, it might mean in the last week, it might mean in the last hour, depending on how your infrastructure is kind of set up. But it's based on actual events and it's based on logging, and that is kind of what your analytics stack is telling you. It's going to tell you how many daily active users you have. It's going to tell you how much revenue you're making, all these kinds of things. It's actually telling you what is happening 100% for real if you have a good stats platform. Sometimes it tells you about 90% what's happening. Data science is about telling you what's going to happen tomorrow. And that is kind of the big divide in my head between the two. Data science looks at the stats that we've got. It goes back into the historical data and looks for what predicted certain outcomes. So what do I mean by that? So like here we have, yeah, I can do a mouse pointer. So this is where we are today. And this is maybe 18 months, and we're going to go back a year and say, okay, well, what happened here? And let's look at this data, and then look at what happened in the next 6 months. Okay, well, now we've got a good sense for that. Let's look at what happened in this 6 months and try to kind of predict what's going to happen in the next 6 months or week or 2 weeks or whatever the time period is. So it could be something like, going back and looking at kind of what did this player do and where did they end up. Data science is not, these are based on things that I have been told or heard, data science is not a silver bullet, no matter what your executives tell you. It's not going to solve all your problems. The more things that you say, oh, well, shrug, silver bullet, we can do it through data science, the more complex and hard the problem's going to get. And really, targeted questions work best. It's kind of a very fine laser rather than a silver bullet. It's not able to answer why questions, and that's why I corrected myself a little earlier. All we can do with data science is look at what has happened, and then we can go, well, this is what we think might happen. But at the end of the day, all we're really doing is going from, this is the stats that were logged, this is the stats we think will be logged. And it doesn't give us any insight into why. It doesn't give us anything about player motivations. But the next point kind of does, because it's not a replacement for strong game design. It's not going to be a case where data science can actually replace game design. Well, give me 20 years. But it needs that initial data to kind of front load to work out the historical data in order to start making predictions. And that kind of gets us to where the why comes in, because you still need game designers and you still need people who understand what's happening in these games and why that might be happening. And being able to make that link between the two is actually really important, and why designers still will have a job for the foreseeable future. So some examples of things that we can do with data science. Likely to churn is kind of the canonical example. So we look at patterns of player behavior and say, okay, well, these people left the game. So if we see these patterns of behavior, and that might be, you start playing every day, and then you come back less and less and less, and then, well, actually, if you start playing less, then you're going to leave. That's a really simple one that I'll give you for free. Difficulty progression is also something that kind of gets a lot of attention. Like, certain people are going to like to play or like to receive a certain amount of challenge over time. So that might be like a really challenging thing and then gradually getting easier for a little bit and then a really challenging thing. Or it might be the opposite. It might be starting off easy, ramping up, getting easier, or just going through the roof on hard. The point is that data science gives us the ability to kind of look at what we feel is working for people and what experiences they're receiving, and then kind of use that to generalize to, okay, new person, what should we do for them? There are 3 questions to that, though, that makes it a very challenging problem to come back to this kind of silver bullet thing. So difficulty progression, I feel, is kind of very much a silver bullet kind of situation, because we need to identify groups of users. We need to determine what their preferences are, what's working for them in terms of like difficulty, and then we need to be able to actually build that and replicate it in the game, and it turns into a nightmare situation. So if it's a nightmare, why do we want to do it? At all, ever? Mostly because this is Battlefield 1942. It's about 15 years old at this point. And this is Battlefield Hardline, so coming in sort of 14, 15 years into the future. Graphics has got so much attention and so much investment, but the game hasn't really changed. It's not actually updated and kind of providing a new way of approaching games. Graphics are increasingly not where we need to be putting our attention, says the AI programmer. No, it's true though. I mean, like, how much are we spending now on engines that are rendering just that little bit more sort of shiny, that little bit extra? It's all turning into this giant diminishing returns situation. And that's even happening on mobile. So, this is Infinity Blade 2 and CSR Racing. Bit of CSR Racing just to serve the corporate masters. But these are, graphically, they're really good. And these are on mobile devices. We are running out of kind of scope for growth in this area, as anybody who's tried to play one of these all-singing, all-dancing games might know from just trying to hold it in your hand while it turns into liquid fucking metal. We are pushing this stuff as far as it's going to go, and we need to be looking at what happens next. And there's another reason. We approach games particularly in the mass market, as one size fits all. But we know that that's not true. We know that there's like 30, 40 people in this room, and there's probably like 50 different games we could make based on our tastes. One size fits all is not really the way forwards, and yet it is the way that everybody kind of approaches stuff. Here is the game I made. Like it or don't like it. Well, we can do better. We can kind of tailor what's going on, because people come in all different shapes and sizes, as I think Sherry was talking about earlier. And we need to be addressing this market, these different tastes, and we can do that by using data science to identify who these people are and what they're actually going to engage with, by looking at what works and what doesn't work in the data. So this is an example I often come to. This is actually not a data science problem, but I think it exemplifies it very well, with apologies to Sherry for the clearly sexualized content. This is not my fault, but this is from Silent Hill Shattered Memories, 2009-ish. And being a Silent Hill game, what they were able to do was kind of start the game in a psychiatrist's office. And as part of the narrative, the guy was kind of giving you this, going through questions and kind of asking you to pick a choice on this question and pick a choice on that question. It was a mock-up of a psychiatric evaluation. What the players didn't realize is it was actually a psychiatric evaluation of the players. And they were getting to a Myers-Briggs kind of categorization of what each player liked and didn't like. And based on that, they were showing different content packs. So this is an example of, this is actually the same scene in two different content packs. And you get shown the one that you would, that it's felt would resonate with you. So we've already seen this kind of approach of tailored content. But now, it's kind of fair to say that not every game can start in a psychiatrist's office. So how can we kind of get to that same insights? And the answer is data science. So, assuming that the why has convinced you that really you guys ought to be, as leaders, thinking really hard about data science, thinking about maybe setting up a data science team. I know some people who are available for hire. What can you do to set that team up for success? So to start out with, you need to be aware that not all data scientists are created equal, and there's kind of two things that I mean by that. One is that I was saying earlier that data science has become this kind of hot buzzword, and that means there's a lot of people putting data science on their resume who are not data scientists, who are, for example, tennis coaches. I have seen that one. But hey, not many people know about data science, so hey, if I slap it on my resume, maybe I'll blag my way into a job that I'm not qualified for. That's what I did. But when I say that not all data scientists are created equal, I also mean that even people who are qualified as data scientists are, like, it is a very nebulous term. It covers a lot of different disciplines. So you need to have a mix of kind of math-heavy data scientists and also computer science and programming heavy. And if you could actually slip in some games in that, that would be really cool, but it's very hard to do. There's not that many people sitting at the intersection of kind of data science and games. But if you can find somebody, that is really important, because that person is going to bridge the language gap between the two. And if the last 9 months of my life is anything to go by, there is a huge language gap between what game devs mean by terms and what the math guys mean. And that team composition is obviously going to have a really big effect on what you can do. If you have a team that's very math heavy, then you're going to be building a lot of models. If you have a team that's very programmer heavy, you're going to be building a lot of tools. Kind of understanding and matching that bias is really important. And then you've got to establish a data culture inside your studio. And this is actually quite a good kind of quote from Satya Nadella. Insights can come from anywhere, and anyone, anywhere at all, which is true, but it only works if kind of the data is actually available. And that is the big problem that we often find. You need to have a really strong commitment to logging data, to gathering data, to analyzing data from everyone, from all your stakeholders. You need to start gathering that data early and often. You need to be kind of making sure that as you come through prototype all the way through, you're logging data and you're building that picture of what's happening in your game. And logging failures cannot be tolerated. If you're working on a live game, in particular on mobile, this is absolutely a P0 issue. A I have heard, oh, we'll fix it in the next release, which with the kind of usual release schedule on mobile, that cadence is about once a month. If you don't get it into QA this time, then the fix will probably actually be about 6 weeks, 7 weeks, by which point you have lost 6 or 7 weeks of data because the logging wasn't working right. This is not something that you can do because all you're doing is pushing everything down the pipe further. Really bad times. And when I say a data culture, what I mean is that everybody has to have a connection to that data. And we have to be using the data for more than just business metrics. So designers can be thinking about data in this way. You know, we've seen really cool visualizations of like where people died in a level as a heat map over the top of that level. That's data. Difficulty curves, that's data. All this stuff is data. UI artists, you know, which button gets clicked, which button doesn't get clicked. All of this stuff is very relevant and can be picked up from any kind of decent stats platform. And it's not business metrics. It's not all about revenue. It's not all about retention. It's just got so much more power to streamline everything that we do. So, okay, so you've got your team. You've got your data culture. Now we need to get onto the hard one. Because you need to address your executive culture. Because somebody's going to come along and they're going to say, hey, we have a model that can predict with 95% accuracy who in our game is going to pay, assuming it's a freemium game. Guess where I work. To get to 95% accuracy on a model of who is likely to pay, all you have to do is say nobody ever is likely to pay. Nobody's going to pay, 95% accurate, thank you very much. We need, and you turn around and go, you get these executives who go, oh, 95% accurate, brilliant, 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 let's do something with this. Well, actually, let's hold our horses a bit because you need to go back to school and know a bit more about stats. So when we talk about accuracy, we actually need to talk in meaningful terms. We need to talk in deeper terms than we are doing. And that's got to be about stuff like precision and recall. Who here knows what precision and recall are? Not enough of you. So precision are the people that you're identifying as being payers or non-payers correct. And then recall is like, of all the payers that you might have picked up, how many did you pick up? So it's a more nuanced way of talking about this accuracy that actually says, okay, well, you're 95% accurate, but your recall is shit. So your model is shit. Bye. That's what we need to have executives able to do when you have a data science team in order to call bullshit when the data science team starts spouting bullshit. So, okay, now we have a team, we have a culture, we've got the executives that can actually talk about this stuff in a really meaningful way. Now we need to talk about how we're going to engage with the game teams. Because all the fancy math in the world done on a whiteboard doesn't actually help make better games, turns out. So we could do a central model, and in a central model, basically your team sits centrally and services requests as they come up. So the game team kind of comes along and says, hey, we would like to do this, and you say, okay, well, we'll put it in our queue, and we'll figure out what we're going to do, what the priorities are, and we'll get to it. Or you could do it as an embedded model, which is kind of like, well, okay, we have a high priority game, we're going to assign a data scientist to that game, and then the people, the product managers on that game are then going to kind of interface directly with the data scientist. When the scientist needs more support, they're going to come to us and they're going to kind of figure it out. And then over time, the game is probably going to decline, or it's going to be deprioritized, or we're just going to solve all the things, in which case we need to move on, so we pick the next high priority game. So this is something that, as a large corporation, Zynga's kind of been struggling with a little bit from our point of view. We've tried it both ways. There are pros and there are cons. I have a slide here with the pros and the cons. So on a central team, you actually retain autonomy, and you can do the things that you feel need to be done. But the game teams have a lot less buy-in, and what tends to happen is you build this fancy model, and they go, oh, that's nice. See ya. On the other hand, on an embedded model, they have a lot more skin in the game because generally they're paying for that data scientist. So now it's on them to actually do something with that, or it costs them. So they really want to be enthusiastic and do something, but they don't actually necessarily report to people who know what's going on and how data science works and this kind of stuff. So they end up spinning their wheels doing bullshit. So So from a kind of point of view of like which is best, both have really strong negatives. If you go the central route, you may find that you're not getting enough buy-in. If you go the embedded route, you might find that you're working on the wrong things. There's other kind of issues here, but I can see that I'm going to be pushed for time a little bit, so I'm going to skip over this one. So let's assume that you've picked a model. At some point, you're going to have to prioritize stuff. And there's a load of things that you could do. So how do you decide? Because like estimating the outcomes of this stuff is really tough. Because the outcome of a model is nothing. It's a pretty graph. What you actually need to happen is the game team to pick that up and do something with it. And like I said, that's sometimes a challenge. And sometimes they do something really stupid. Sometimes they do things that are really good and really like drive it. But you can come up with like, well, actually, if we do this, then I think that there's like, oh, there's $20 million sat on the table. And then you implement it all and they do something really bad and nothing happens. You get nothing back because like the model's broken, the implementation's broken. The way it works on the client is not working out right. So it's a very challenging thing to actually get to a point where you can prioritize this stuff. Also, you kind of start off going, okay, well, I'm going to look at this data and I'm going to work out who's likely to churn. And you look at the data and there's no way you can build a model for that. There is no rhyme or reason to any of it according to the data. So it goes nowhere. So now you have a project that is failed. So some of these things are high risk. And then you've got the skill set considerations. You know, who have you actually got available to work on this stuff? Factor all that in and you eventually get to a point where you can prioritize this stuff. But it's hard. But let's say you do it. So now you've got your data culture, you've got your team, you've got your executives, you've got your prioritization, you know what kind of engagement model you're going to use. How are you going to do the work? Well, it's game development, so we have to be agile, right? But a data science project is very linear. And you sort of start out by pulling the features out of the database, and then you visualize and explore them and kind of see what's going on, and then you build your model, and then you verify it. And there's not really that much that suits itself to an agile model there. And also, like, we're looking at this, it might take a month for a model to be built. It might take a quarter if it's a really big, complicated kind of multi-model process. So none of this is really lending itself to working with Agile. But at the same time, we've got to interact with teams that are very agile, that are kind of busting themselves, putting out new releases, kind of figuring out how to do all the development. And that is always going to be an agile process because that's the way things have gone. So how do you interact with that? I don't have answers to these questions, but these are questions that you actually need to be asking. Because I can tell you now that if you get it wrong, you end up with a team that's really kind of not going in the right direction, and then you have to kind of stop, reassess, figure out what's going on, and try better. And that's the process that we've been going through, is kind of just trying to figure out how to do this properly. And I wouldn't say that we've not got there yet, because I think we're a lot more effective than we have been previously, but these are open questions. I don't think that anybody has actually got really good solutions for how to go about running these projects, given the nature of kind of their work versus the integration against the other side. So that's kind of the how to do it. And I'll give you two little tips very briefly, because these are ones that really changed my life completely from the first couple of months of kind of starting as a data scientist. Two pieces of software. The first one, unfortunately, is paid, so you'd have to buy licenses or acquire it however you acquire it. I'm asking no questions. Tableau is, for my money, it's best in class for visualization of data. So when you pick up the data and kind of go through, like, where are these data points, what's happening, how can we kind of get a sense for what's going on? Tableau is I was trying to do all this in Excel, and I wanted to blow my fucking brains out. And then I started using Tableau, and it's like, oh, okay, this is how we're meant to do it. So that one would be a recommendation to anybody who's kind of thinking of heading in this direction. The other one is open source, and when I talk about it, a lot of people have not heard of it, even data scientists. It's called KNIME, K-N-I-M-E. It's an IDE based on Eclipse, and it is just drag and drop data science. So here we have a decision tree learner, which reads in from a file by dragging it and dropping it into the workspace, wiring it up to the color manager, Then we partition it. So I guess this file has a lot of rows. So we partition it into a training set and a test set, pass the training set off to the learner, build a predictor, and then score what the prediction is coming out with. And that is how you build a model in KNIME. It is dead easy. And like I say, I don't see a lot written about this tool, so that's another free piece of advice for you. Okay, so wrapping up. The prevalence of connected devices and kind of the way that we're approaching development now means that we have more potential for insight into player behavior than ever. We have so much data available. Getting data science right can be a game changer. It can revolutionize games. But successfully integrating a data science team against a game team is really a non-trivial problem. Getting that to actually mesh is really hard, and it's going to present you a lot of leadership challenges. I hope that I've helped to shed some light on that, because those are the bits that I've actually been finding fun over the last 9 months. And before I go, I should say that we're hiring. We have open positions for data scientists. We're looking for a data science project manager, and feel free to grab me at some point. And yeah, so I am at Luke D on Twitter, and there's my Zynga email address. And thank you very much for sitting through that. So I think I've got a couple of minutes if there's any questions, otherwise escape for coffee.
Okay, apologies in advance for my question. I'm not clear how to, you have a slide on why, and I feel like it's much easier to understand the benefits of data science to games as a service, and particularly online games, particularly free-to-play games. I have a hard time understanding how it can be applicable to a more traditional AAA console release. Certainly we do data analytics based on playtest and things, but
Chances are it's going to be tough. I mean, a lot of data science relies on the data gathering, and a lot of kind of traditional, the kind of AAA space is still being forced into kind of not requiring a net connection, kind of not necessarily building out on top of stats platforms like that. So yeah, there's going to be limited value there, depending on who you're with. I mean, like EA, they're pushing very hard on microtransactions, so they are probably figuring something out. But then again, as soon as you start bringing in microtransactions, you're talking about moving away from AAA, so or from classical AAA, shall we say. So yeah, so it's not necessarily, I already said it's not a silver bullet, and it's not necessarily applicable for all use cases, for sure. And I am coming at it from a very skewed, mobile-centric kind of point of view.
What advice would you give to, say, like, indie projects who couldn't afford a data scientist?
Learn. You can go out and you can figure, like, so, I mean, it's easy for me to say that, right? Because my background is in AI, this is kind of my stuff. We were working with 2 stats platforms when I was indie before I came onto Zynga. The data can be all there. There is nothing, like, other than ridiculous inflated San Francisco salaries, there is no particular reason that data science should cost you that much. At the end of the day, a lot of the kind of processes behind this stuff, well, like that KNIME thing. KNIME is free. Your stats platform can be free. You can export from one to the other pretty easily. You can do this on the cheap pretty quickly. And then if you look at a lot of the stats platforms now are kind of looking at this kind of stuff. So I'll call out Delta DNA as one that is particularly switched on. They do a lot with kind of targeted segments. So you can actually group the users into clusters and present different experiences based on that actually natively within that stats platform. So you can do this stuff for indie projects cheap and have it be, 80, 90% of what you would pay ridiculous money for.
Can you clarify a little bit what you meant about the difference between a math-led versus a CS-led data team?
Okay. At the end of the day, it comes down to kind of, this is not necessarily a strictly kind of, this is my experience of the teams I've worked with. There are people who come at this from a very math-heavy background. These are the folks who, when you ask them to put together a PowerPoint deck, are going to be figuring out how to put Greek symbols into their deck. And then there is the folks who are coming at it from a more computational, algorithmic kind of background. So rather than trying to solve the problem using a formula, they're actually looking for kind of, to go back to the same analogy, in their PowerPoint deck, they'll be figuring out how to use the console font, and how to best make kind of, okay, well, this is actually code. It's kind of, I feel like it's two distinct mindsets, and it's just kind of, both can solve a lot of these problems, because at the end of the day, they're different ways of kind of expressing the same problem. But if you're kind of CS mindset, then you're much more able to kind of build a tool rather than kind of build if you build a function, then you need to kind of have somebody else wire up the inputs and the outputs and all that kind of stuff. From a computer science background, you can just kind of go, right, here's the end-to-end service, bang, done. Does that answer it? Okay. Then I hope it did answer it, because we're done. Okay, so I'll be hanging around if anybody wants to come chat, and I guess we're on a break for coffee.